Hello. Hope you are well. Welcome to my 3D bitmap engraving tutorial part 2. If you stumbled on this video and is interested to program 3D or 2D engraving on an CNC 3-axis milling machine or router, please follow the part 1 tutorial. Part 1 will show you how to get your design into your device and how to get your CNC output file off your device. Okay, let's first look at 3D pixel engraving of an image or photo. Navigate in Windows, explore to your image. Open the image in Photos. We are going to convert the image to a grayscale. Drag your mouse all the way to the left to convert to grayscale. I will leave the light as it is because I think Leonardo did a good job here. Save the image and close the app. Open the image in the Paint app and follow what I am doing. If you select the image to be engraved to large, your cycle time will be very long. Rather, scale your design with the width of engraving label in the app. Now you can save the image on your PC and exit the Paint app. Copy your image like in tutorial part 1 onto your phone in the DCIM camera directory. Let's run the app. Like in my part 1 tutorial, we must scale the width of the image to whatever size you want your design to be. Always use grayscale for 3D engraving, and also always leave space around your images in the form of white pixels. Especially if you use vector engraving. In vector engraving, the cutter will stay down until it sees a white pixel and then lift up to safe distance. In pixel engraving, the cutter will lift to safe distance after every pixel. Use as a rule pixel engraving when you engrave photo images because photos are made of pixels. The left engraving on the London Tower top is done in pixel engraving and the right side vector engraving. So, decide for yourself. If 3D engraving is selected, the app will calculate the Z depths according to the grayscale RGB values. A white pixel will not be machined and a black pixel will be the maximum depth you specify. All the other grayscale pixels will be machined in between in the correct ratio according to your maximum selected depth. The Tool Depth 60 button will calculate the maximum depth according to your scale width you specified at the top. The black pixels will then be the correct depth. The calculation is made assuming you use a 60 degrees engraving tool. You then have to replace that new calculated value with your maximum depth of 3D engraving label. Now your picture will look exactly like your photo image. Click on the Post-Process button. When the progress bar is done and the bottom label is green, you can close the app. Congratulations, you generated your first engraved image CNC program on an Android device. Copy your output file from your device documents directory onto your PC. Let's wrap this up. To machine a bump map is pretty much the same deal. Definitely leave space around your image and use vector engraving. No need to calculate Z depths. I normally, on small jobs like these, use a 1mm ball nose cutter with a Z depth of about 1.5 mm. I think there is hidden potential in 3D engraving of a grayscale image using ball nose cutters. Especially in the wood router industry. I have created a few grayscale maps with RGB values between 0 and 255 and machine it like surface machining. Vector engraving with your pixel size as a step over. Always test your output file with the USG platform, also known as the Universal G-Code Sender. As you can see, the XNEY0 is always on the left top of your design. This is the end of the 3D bitmap engraving tutorial part 2. Thanks for watching.